Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a numerical number 2 which is based on signals with the complex conjugate poles. Now we have studied a problem number 1, so please go through that so that we will get the idea how to solve a problem number 2. So let's move on to a problem number 2. Obtain the inverse z transform of signal x of z 1 plus 2z inverse plus z raised to minus 2, and in denominator we have 1 minus z inverse plus 0.356 z to the power minus 2. Now here if I multiply 0.356 into 1, then you can say the answer is 0.356, but the addition of both of them is not equals to 1. So we can directly say that it is a complex conjugate poles, or else if you use a calculator, then also you will get the idea how to calculate or how to identify the complex conjugate poles. Now first of all, my aim is to convert both this numerator and denominator into positive power of z. So we'll multiply numerator and denominator by highest power of z, that is here. Look at here, in denominator the lowest power of z is z to the power minus 2. If I multiply numerator and denominator by z to the power 2, then the lowest power is removed and you will get only the positive power of z. So we will solve this numerical first. So first of all, I'll multiply numerator and denominator by z square. So this 1 is multiplied with z, so you will get z square. Then here the order is minus 1, but if I multiply it by z square, then one order will be removed, so you will get a 2z, and the last one z to the power plus 2 and z to the power minus 2. The powers are gets added and you will get the answer 0, so z to the power 0 is always 1. Now we'll multiply denominator, or you can say z square in the denominator, so you will get z square minus z plus 0.356. Now what I'm going to do is, first of all, while calculating inverse z transform, one z must be kept on the left hand side or denominator of left hand side. So what I will do, I'll multiply, or you can say I'll divide both the sides by z, or you can say I'll multiply numerator and denominator by z. Answer will be nothing but same, because after multiplying I'm going to shift that numerator z, extra z on left hand side, and that will comes in denominator. So simply you can say that divide both the sides by z. Now basically what we want extra z. Whenever our function is a normal or positive power of z, we want extra z in the left hand side denominator. So what I'm going to do, I'll divide both the sides by z, or else you can say that multiply numerator and denominator by z, then shift the extra z which was in numerator on the left hand side, and that will be on, after shifting, that z will be on denominator side of left hand side. So that's why I can say that you can use both the statements. So first one is much more good, divide both the sides by z. So what you will get, now next is we will find out the factors of denominator. What you will get, these are the two factors of z. First one is a 0.5 minus j 0.23256, and another one is 0.5 plus j 0.3256. Now as look at here we have a 3 poles, so of course I will use 3 different constant. So first one is a, which is z, next one is b, so this is our c. Now what I'm going to do, I'll multiply this denominator with this one. So let's see what answer you will get. This will be our next step. Let's substitute z values in this equation to get the value of a, b and c respectively. So first of all, I'll substitute z equals to 0, because if I substitute z equals to 0, then automatically this b part and c part will be removed. You will get the answer only for a. So on left hand side, what you will get? Only 1, because these two terms carries z. Only 1 is a constant, so I'll write 1 only. And if both this z replaced by 0, then what will get? We have studied one formula, a square minus b square, or simply a minus jb and a plus jb. A minus jb and a plus jb is always a square minus a b square. After solving a square minus b square, what I will get? That a value is multiplied with 0.3560, and here we have 1. So I'll shift this 0.356 on the left hand side. So what you will get? Now we will substitute a value of z to get the value of p and c. So the first of all, I'll substitute the complex conjugate value of this part, which means I'll write, or I'll keep 0.5 or real part positive, but the next value is 0.5 minus j 0.3256. I'll substitute this value in my equation. Now look at here. If I replace this z, or you can say this z, by 0.5 plus j 3256, so 0.5 minus 0.5 will get cancelled, and minus j 0.3256 plus j 3256 will get cancelled. So whole term a will be removed. Similarly, look at here in b. If I substitute this z by 0.5, then 0.5 minus 0.5, answer is 0. Minus j3256 plus j3256, answer will be removed. So whole b term is also gets vanished. Only will get the value of c. So I'll substitute this value in my equation. And this c, first of all, this z is replaced by, and then I'll replace this z by this value. And the next point is minus 0.5. I'll solve this whole part first, or left hand side first, and then I'll multiply this part. But look at here, 0.5 minus 0.5, answer is 0. Only these two terms will get added. So 0.3256 will be multiplied twice, and then the whole result is multiplied with this answer. So after solving this left hand side part, what I have got? 2.144 minus 0.977j, and then after multiplying this whole bracket with a twice of j 0.3256, I'll get this answer. Now to get the value of c, I'll shift this multiplying part on the left hand side, and we'll calculate the answer of c. So after shifting this value on left hand side, what I have got? These two results. And after solving this part, what I have got? The value of c, which is 0.904 minus 5.966 j, and this is the value of c. Now similarly, we will calculate a value for b, but for that we will substitute again z equals to the opposite, that is complex conjugate value of the value which is substituted for z to get the value of c. This value I'm going to substitute in equation number 2. So what you will get? Basically, if I substitute z equals to 0.5 plus j 0.3256 in my equation, then a term and c term automatically get cancelled, and you will get the answer only for b. Now I'll solve this left hand side part and right hand side part, and then I'll shift this, whatever outcome you will get multiplying with these two bracket, I'll shift this that outcome on left hand side, so you will get the answer of b. So after solving a left hand side part and after dividing it by a product term with a b, I have got this result, and this will gives us a value of b, and I'm going to substitute value of a and b in my equation number 1. Now I have substituted the value of a, b and c in my equation number 1. Now I'll multiply this z on right hand side. So what I can say, if I shift this z on right hand side, both the z will get cancelled. So the first value will be nothing but 250 by 89. Now what I'm going to do, this is the constant part, so that I will write first. And then I'll write z upon this whole term. Now I'll do the same thing with the last part also. So I'll write a constant term first. And then z upon this whole denominator. And now I'll apply inverse z transform on both the sides. So what we will get? Applying inverse z transform. So x of z is represented by x of n. Now first of all, the first term is 250 by 89 and it's a constant term, and we know that we can say that this value is multiplied by 1, and inverse z transform of 1 is always del of n. So I can write 250 by 89 into del of n, and then I'll write this constant part. Now look at here, we can represent this value or equation by z upon z minus a. So I can consider this whole value is my a, but z minus a is equation we required. Then what will be the value of a? Because we know that z upon z minus a, inverse z transform with this is a raised to n into u of n. But for that we should know what is the value of a. So here, if I remove or if I take minus sign common from these two parts, then I can say that my a value is 0.5 plus j 0.3256. So I'll multiply this value by raised to n, and that will be multiplied with u of n. Then plus, again I'll write this constant part. Again I will do the same thing. Here also we have the value of a, and my if I take a minus sign common, then my a value is minus 0.5 minus j 0.3256 raised to n into u of n. And if you want, then you can take u of n common, and if not, then we can stop here also, and this is nothing but the inverse z transform of given function. So these questions are little bit complex, because if you miss any single term, or if you forget to make or mark any sign, then your result you will get a wrong, or whatever outcome you will get, it is completely wrong. So while solving these numericals which is having a complex conjugate poles, you have to give 100% concentration, then you can get the correct answer. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.